Good morning, everybody. Happy Thursday. Today we are going to be learning about Newton's second law. So on Wednesday in class, we learned about Newton's first law. An object in motion stays in motion, and an object at rest stays at rest, unless acted on by another force. But today we're going to be learning about Newton's second law. Your guys' goal is to be able to understand this on a conceptual basis. There is going to be some math that I'm going to be doing today to just kind of help illustrate some points, but really our goal for today is just to understand how does this law work in our world. Let's put aside the numbers for today, and let's just focus on how does Newton's law actually affect us. All right, let's get into it. So, first things first, in word format, here's the law. The total force exerted on an object will be equal to the mass of the object times the acceleration of the object. So for example, let's say you guys are at school and you have to move your desk. You're going to exert a force on that desk when you push it. And that force is going to equal the mass of the thing you're pushing, the desk, times the rate that it accelerates at. Okay. In other words, the force you exert, the units are called newtons, equals the mass of the desk, its units are kilograms, times the acceleration of the desk, and its units are meters per second squared, or F equals ma. You may have actually seen this equation before in 8th grade, which if you have is awesome, and if you haven't, that's totally okay. All right, so what we're going to be doing is we're going to be looking at 3 different scenarios. We're going to be looking at what happens if we try and move a train, what happens if we try and shoot a bullet, and what happens if we try and move a dresser. How do these aspects of force, mass, and acceleration come into play when we're working with these different objects? All right. So first things first, let me just pull up the picture. I think I can get rid of this now. Here's a simple picture of a train. You guys may have seen a train in real life, or you may have seen pictures of trains. Are trains very big? Do you think trains have a lot of mass or very little mass? Trains have a lot of mass. They're huge. So what I'm going to do is I'm going to write in the mass is high. Let's say that we'll give it a number. We'll say the mass is 100. Okay, we won't even worry about the units for right now. Mass is 100. Do trains have big engines? Do those engines produce a lot of force? Why, yeah, in fact they do. So let's also say the force is really high as well. Say it's 100 as well. So what we're trying to figure out in this situation is how fast is this train going to accelerate? Is it going to accelerate very quickly, or is it not going to accelerate very quickly? Well, to do that, we can simply just kind of look at this equation. If the force is 100, then we can substitute 100 in for F. And if the mass is also 100, we can substitute 100 in for the mass. Now, we don't know the acceleration right now, but that's okay. We're just trying to figure it out. So what I can do is I can divide both sides by 100. There we go. We're going to divide both sides by 100. And when we do that, those 100s, they cancel out. And we're left with the acceleration equals 1. Okay, so what do we learn from this? Well, we learn from doing this very simple calculation that when the force is high and the mass is high, the object is going to accelerate fairly low. It's going to accelerate slowly. And that makes sense, because remember, our goal for today is to understand this from a conceptual point. When you see a train, let's say you've got a train that is still, and the train starts to move forward, chugga, 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 and it starts to accelerate. When a train starts to accelerate, does it accelerate quickly or slowly? It accelerates pretty slowly, only at about 1 meters per second squared. Let's try a different example. Let's think about a bullet. So you guys have probably seen like movies or things like that where people are shooting guns. Bullets, are they very big? Not really. Bullets are pretty small. Their mass is pretty low. So let's give it, a number. Let's just say it's got a mass of 1, just to make things a little bit easy. When we shoot a bullet out of a gun, does it move really fast or does it move slowly? Well, it moves pretty fast. It gets out of that gun. It goes from being stationary to moving really fast. And so its acceleration is high. Okay, so if it has a low acceleration, if it has a low mass and a high acceleration, what would we expect the force to be? Well, think about it in terms of the equation, right? We don't really know what F equals right now. But if we know that the mass is low and the acceleration is high, how does that affect our force? Yeah, our force is also going to be a big number. Because 1 times 100 is still 100. So our force is high. Now, does that make sense? Well, when we're thinking about a gun, I'd say, yeah, it does. That gun is producing a lot of force when it fires that bullet. And so it makes sense that it would have a lot of force behind it. Okay. You guys can't see this right now, but I have this big, giant wooden dresser in my room. Maybe you have a large dresser yourself. So I've already said this dresser is really big. Now, I'm not very big. I'm honestly a pretty small guy. I weigh 150 pounds. This thing probably weighs 4 times that. Like, this is solid oak. It took 3 guys to get it into this house. Because, like, both my wife and I use it. It's like 2 dressers combined into one. And honestly, I don't think it's ever going to leave its current resting place. Because it was so hard to move. Okay, so if it was really hard to move, does that mean it was accelerating high or low? If we were just barely able to move it, was its acceleration high or was it low? It's low. It would have a low acceleration because it was really moving very slowly. The 3 of us were just taking half steps trying to get it into this bedroom. Okay, so what does that mean for our force? Are we going to have a high force required to move this object or a low force? What do you think? Well, let's find out. So we don't really know what the force is right now. But we do know that our mass is high. Let's give it a big number. And we know that our acceleration was low. So how does that affect our force? Yeah, you got it. Our force would be 100 as well. It would be high. So this is honestly really applicable to your guys' lives. You can use Newton's second law in all kinds of situations. If you're at a basketball game, think about how much mass that basketball has, and think about how hard you need to throw it to get it into that basketball hoop. If you're driving a car, which has a lot of mass, and also can produce like tons of force, those are things that you can think about, is how much like energy it would take to move that and how dangerous a car can be, right? Because if something has a high force and it's also moving at a high acceleration, it can hit things pretty hard. Another thing that I want to make sure you guys understand is that these are relatively simple examples. We're only using the numbers 101. And when you actually look at the real world, the numbers are never this nice. And so that's always something important to take into account. The main goal behind today is that you guys can understand, okay, it's a big object. In order to get it to accelerate, I'm going to need a lot of force. Or it's a little object. In order to make it accelerate, I'm not going to need a lot of force to just make it move a little bit, but in order to make it accelerate a lot, I'm going to need a lot of force. That is your goal for today. Hopefully you took that away from it. If not, feel free to come to office hours with some questions. I'd be happy to help. Until then, I'll see you later. Bye.